Sine 60, prove that sine 60 equals 2 sine 30 cos 30. Sine 60, when you put into the calculator, not so much you're not allowed to use the calculator, but you can use your tables and you get root 3 over 2. Then you go for sine 30, which is 2 times a half. And then you look up cos 30, which is root 3 over 2. Now, 2 multiplied by a half is 1. And basically you have root 3 over 2 equals root 3 over 2. And you've basically proved that it works. Might as well do part 1 while I'm here. They don't take long at all. It's going to be 1 minus, now this means sine 30 squared. Sine 30 squared is minus a half squared. On the other side is cos 30 squared. So you look up what cos 30 is in your tables. It's root 3 over 2 squared. A half squared is a quarter. 1 minus a quarter is 3 quarters. Multiply this out, you're going to get root 3 over 2 multiplied by root 3 over 2. Root 3 multiplied by root 3 is 3. 2 multiplied by 2 is 4. 3 quarters equals 3 quarters, they are equal. Moving on. Number 13. Find the values of x and y in the given triangle without using the calculator. Okay? Ignore the left triangle and just use the left triangle for x. Okay, so the left triangle, doesn't matter what's in it, we'll call it the pink triangle. This one here, basically, in a nutshell. So we have 45 degrees, you have x, and you have 3 root 2. Now guys, what 2 values do I have here? What 2 sides do I have? I want to know the adjacent, and I have the hypotenuse. Adjacent and hypotenuse means which function? Which function is adjacent and hypotenuse? Cos. Cos 45 equals adjacent divided by hypotenuse, which is going to be x over 3 root 2. Find out what cos 45 is using your tables. It's 1 over root 2. Now, what you notice about both denominators, what number do they have in common? Root 2's, so they cancel. Or alternatively, you could have cross multiplied the full thing up and you would have got 3 root 2 all over root 2 equals x. And then you can cancel them anyway. The answer is x equals 3. Is that alright? We got that one out, number 13. Okay, hopefully you've got them out. Now, 13 part 2. We're now going to work on the green triangle, which is located here. And in the green triangle, we have it 60 degrees. We know y is y and 2. Compared to the 60, what is the number 2? What's the name of the side? Adjacent. Compared to the 60, what is the name of the y? The side y. What's its label? It's a hypotenuse. So, cos 60 equals 2 over y. What do we do next? Cross multiply up the y, so you could technically have y cos 60 equals 2. Then bring down the cos 60 underneath. Y equals 2 divided by cos 60. And what's your answer? You need an answer bigger than 2 for this to work. The answer is 4. So the hypotenuse is 4. Now here comes number 16, the one that most people ask me in the class. Okay? A field is in the shape of an equilateral triangle as shown. Each side is 40 meters in length. So that suggests 2 methods in finding the area of the field without using a calculator. Okay. 2 methods. Method A. Cut the triangle down the center. Everybody see that? Cut the triangle down the center. Okay? The method I want to use is a half base multiplied by height. I don't have the height though, do I? So can anybody tell me how to calculate the height? How do you calculate the height, guys? What length is the hypotenuse in this triangle? Can anybody tell me? 40. What length is the this part down here? It's 20 because it gets halved. And now we can figure out h. So we're going to use Pythagoras' theorem, right? So Pythagoras' theorem gets us 40 squared equals 20 squared plus h squared. Bring the 20 squared over to the other side. 40 squared minus 20 squared equals h squared. Use the calculator. Okay, square root that. Answer? 20 root 3. Now guys, what is the area of this then? Half base by height. So the base is 40, and what's the height? The height is 20 root 3. And what do we get? In third form, 0.5 multiplied by 40 multiplied by 20 root 3. It doesn't give it to you in third form, does it? So, calculator, I have an idea. There's a root 3 in there somewhere, isn't there? Yeah? So if we divide by root 3, it's 400 root 3. Let me explain. Ignore the root 3, lads. It's just going to be a half 40 by 20 is 400. 400 root 3. Now guys, the second method, have we used the half AB sine C yet? No. Okay. There's a formula that says a half AB sine C for the area of a triangle. Now, the area of a triangle, for this formula, it'll show you the diagram beside it. And what it'll show you in the diagram is this. You'll have a triangle, and what it'll say is you'll have C and small c, A and B. Now, what it means is a half multiplied by any two lengths, so it can be any two lengths that make an angle. So it's any two lengths and the angle in between. So a half, so 1 second, a half these two lengths multiplied by the angle in between gives you the area. That will always work. You got it? A half any two lengths and the angle in between. So for this triangle here, what is this angle here? Can anybody tell me? Has to be 60. Why does it have to be 60? It's an equilateral triangle. Now that we've done that, half any two lengths and the angle in between. What are the two lengths then? 40 and 40. So it's going to be a half 40 times 40 sine C. What's sine 60 in your tables? Root 3 over 2. Half 40 times 40, root 3 over 2. Put it into your calculator and excluding the root 3. Don't put the root 3 in because we don't want that to get mixed up again. So you're going to do a half 40 by 40 by another half. And you should get 400 root 3. Okay guys, that's